Hey Global Impact students, this is Mr. Ellinger. Today's lesson is on addition, subtraction, multiplication, and division of real numbers. We have two learning targets for this lesson. Find the sums and differences of real numbers, and find products and quotients of real numbers. Essential understanding for the lesson: any real number can be added or subtracting using a number line model or using rules involving absolute value. Subtracting a real number is equivalent to adding its opposite. A minus B equals A plus negative B. This means that every subtraction problem can be written as an addition problem. The rules for multiplying real numbers are related to the properties of real numbers and the definitions of operations. The product or quotient of two real numbers with different signs is negative, and the product or quotient of two real numbers with the same sign is positive. Background for the lesson: addition and subtraction are inverse operations. Number lines can be used to aid in the concept of adding and subtracting positive and negative numbers. Remember that every subtraction problem can be written as an addition problem. This will make your life much easier many times in your mathematical career. Multiplication and division have an inverse relationship, just as addition and subtraction are inverse operations. What this means is that two operations essentially undo each other. Also, division by 0 is undefined. The question is why? We'll take a look at that. All right, our first example, we are going to add using a number line. We can add positive and negative numbers using a real number line. Positive numbers are to the right of 0 on the number line, so we move to the right on the number line to get to that number. Negative numbers are to the left of 0, so we move to the left to get to those numbers. So here we have some examples. 2 plus 6. Now we know that 2 plus 6 is 8. Hopefully we can do that one in our head. But here's how we could use a number line to do this problem. So here's 0. We're doing 2 plus 6. So let's go to 2, positive 2. So here we are. Here's positive 2 on a number line. And then from there, we're going to add 6, which means we're going to move 6 units more to the right because 6 is positive. So we go 1, 2, 3, 4, 5, 6. 2 plus 6 is 8. Next example, 4 plus negative 7. So we'll start at 0. 4 is positive, so we'll go to positive 4 on the number line. And then we're going to add to it negative 7, so that means we're moving to the left. So from 4, we'll go 1, 2, 3, 4, 5, 6, 7 units. And we wind up at negative 3. So 4 plus negative 7 equals negative 3. Negative 3 plus negative 2. Well, we'll start at 0. Negative 3 is our first number, so we will move to the left to negative 3. And then we are going to add to that negative 2. Well, negative 2 means we go left 2 more units. So we wind up at negative 5. So negative 3 plus negative 2 is negative 5. That's how we can use a number line for addition and subtraction. All right, absolute value. What is absolute value? Well, a lot of times when we ask that question or answer that question, a lot of people say, well, absolute value is just whatever the number is, we just make it positive. For instance, if we wanted to know the absolute value of 4, we know that that is 4. If I ask you the absolute value of negative 4, you would say 4. Whatever goes in here or here, we just make it positive. The question is, why is that? Let me give you a definition. Absolute value is distance on a number line. From 0. So I'll use my 4 and my negative 4 examples here. So here we have 0 on a number line. Here's the number 4 on the number line. And here is negative 4 on the number line. Okay? Now if I asked you how far is it from here to here, from 0 to 4, you would say 4 units. If I ask you how far is it from 0 to negative 4, we should say 4 units, because distance cannot be negative. Distance is positive. We can't measure negative distance. Okay, we can't travel a negative distance. We can only look at positive distances. It doesn't make sense to talk about negative distance. So from 0 to negative 4 is 4 units. That's absolute value. Some key concepts here. When we want to add numbers with the same sign, we can add their absolute values, and then the sum has the same sign as the add-ins. Okay, add-ins are the numbers that you are adding. So in this case, 3 and 4 would be the add-ins. 3 plus 4 is 7. Negative 3 plus negative 4, we'll add the absolute values of those. The absolute value of negative 3 is 3. the absolute value of negative 4 is 4. 3 plus 4 is 7, but both add-ins are negative, so we'll put our answer as negative 7. Okay, adding numbers with different signs. To add two numbers with different signs, we subtract their absolute values. The sum has the same sign as the addend with the greater absolute value. For instance, 3 plus negative 4 equals negative 1. Here's why. Using this definition, 3, absolute value of 3. The absolute value of negative 4 is 4. 3 minus 4 equals negative 1. Just to double check, in our two addends, the greater absolute value is 4. So the addend, negative 4, it's negative, so our answer should have a negative sign on it. We have an inverse property of addition. For every real number a, there is an additive inverse, negative a, such that a plus negative a equals negative a plus a, which equals 0. Basically what that's saying is, if you take a number like 14 and add it to its inverse or its opposite, you're going to get 0. Another key concept, subtracting real numbers. And this might seem very minor, but this is a huge thing to remember moving forward in any math class. You can always change subtraction problems to addition problems. So for instance, in general, we can take a minus b and rewrite that as a plus negative b. This is going to make things much easier for skills that we will need to learn in later math classes. Example, 3 minus 5 equals 3 plus negative 5, which is negative 2. All right, so let's look at some examples here. In this unit, we're not using calculators, so we need to be able to do this problem without a calculator. So negative 16 plus negative 8. Well, we're adding two values with the same signs. So what we'll do is we will add their absolute values. 16 plus 8, which is 24. And then both of our add-ins were negative, so we know that our answer is going to be negative 24. Adding two numbers with opposite signs, we will subtract their absolute values. So this is 9 minus 11, which is negative 2. And then just to double check, negative 11 has a greater absolute value than 9. So our answer should have a negative 4 minus negative 8.7. Well, we had a rule that says we can turn any subtraction problem into an addition problem by adding the opposite. Okay, so here we add negative 8.7, so we're going to add positive 8.7. Well, we don't really need the two addition signs, so this is asking us what is 4.8 plus 8.7, which is 13.5. And just a question to consider, get you thinking, for what values a and b does a minus b equal b minus a? Meaning, are there any two numbers that we can subtract one way and then change the order of the subtraction and still get an equivalent or an equal value? And the answer is yes, there's one set of values here. A and b are both 0. 0 minus 0 equals 0 minus 0 because 0 minus 0 is 0 and 0 minus 0 is 0. That's a true state. All right, here's an application of adding and subtracting positive and negative numbers. A robot submarine drives 803 feet to the ocean floor. It rises 215 feet as the water gets shallower. Then the submarine dives 2,619 feet into a deep crevice. Next, it rises 734 feet to photograph a crack in the wall of the crevice. What is the location of the crack in relation to sea level? So what I have here on the left is I basically just took a number line and made it vertical instead of horizontal, and 0 would represent the water level. Here we have our water level. And we have this submarine that's underwater. So we want to kind of model this with a drawing here. The submarine starts out at sea level at 0. It says it dives 803 feet. So 803 feet dive means it goes down, right? So this submarine is right here. It went down 803 feet. That's a negative value. Now from there, it's going to rise 215 feet. So if the submarine starts here, it's going to go up to here, say, 215, that's a positive value. It rises. From there, the submarine dives 2,619 feet. So if the submarine were here, it's going to dive 2,619 feet. And again, that's a negative value because it's diving, it's going down from 0. And then from there, the submarine is here. It rises 734 feet. That's a positive value because it rose. So the question that it's asking us is, what is the location of the crack in relation to sea level? So if this is where the submarine ended up, how far below sea level is that? What is that depth? Well, the way that we calculate it is to just take these values that we got from our information in the problem and write an expression and simplify it. So negative 803 plus 215 minus 2,619 plus 734. Whatever value that is, that will give us the answer to our problem. Okay, so the depth of this submarine, after I simplify this expression, is negative 2,473. So in the context of the problem, we would say that the crack is 2,473 feet below sea level. Anytime we have a word problem, we always want to answer the question, address the problem. This number, negative 2,473 feet, is the correct numerical value that we need to answer the question. But without this right here, we didn't really answer the problem or the question. All right, so when we multiply numbers, one thing that we need to know is that if we're going to multiply two numbers with different signs, then the product's going to be negative. The product of two real numbers with the same sign is always going to be positive, and there are a few examples. We also need to remember that we have this thing called the inverse property of multiplication. For every non-zero real number a, there is a multiplicative inverse 1 over a, such that a times 1 over a equals 1. There's another name for that. It's called the reciprocal, and we'll look at that here in just a second. So an example is the multiplicative inverse of negative 4 is negative 1/4, because negative 4 times negative 1/4 is 1. Again, a pretty basic concept, but a very powerful tool that we will use. Dividing real numbers, division is very similar to multiplication. As you can see here, if we're going to divide two numbers that have different signs, then the quotient, meaning the answer to that problem, is going to be negative. The quotient of two real numbers with the same sign is always going to be positive. Right? Division involving 0. The quotient of 0 in any non-zero real number is 0. The quotient of any real number in 0 is undefined. If you think about what division means take something and divide it up into a certain number of parts. So in the case of 0 divided by 8, they're saying take 0 things and divide it up 8 ways. Well, if you have nothing and you're going to divide it up, you're still going to have nothing. But in the other case, if you take 8 and divide it by 0, you're trying to take 8 things and divide them 0 ways. You can't divide 8 things 0 ways. You can't divide anything up into 0 parts. Okay, you're going to have at least one part. So that's why division by 0 is undefined. Along with the multiplicative inverse that we just talked about in this division concept, we could look at the reciprocal of a non-zero real number of the form a over b is b over a. And we call it, a lot of times we call this flipping a fraction. And that's an okay word because, 2/3, the reciprocal of 2/3 is 3/2, and it looks like we flipped the fraction over, and that's okay to say, but reciprocal is a better word to use. It's a mathematical term. Flipping is not a mathematical term. Multiplication and division examples, again, no calculators. 6 times negative 15, we know right away that the result of this is going to be negative because we have a positive multiplied by a negative. So the question is, what is 6 times 15? And the answer is 90, so the answer is negative 90. Here we have a negative fraction multiplied by a positive fraction. Negative 7/10 times 3/5. Well, right away, we have a negative times a positive, so we know right away that our answer is going to be negative. And the way that we multiply fractions, again, is take the numerators, 7 times 3, that's 21. 10 times 5, the denominators, multiply those denominators, 10 times 5 is 50. Okay, and once we multiply two fractions and we have an answer, we always want to check to see if we can reduce the fraction. We always want things in simplest terms, lowest terms. 21 over 50, we could try to reduce that. It doesn't reduce, so that's our answer. Negative 20 divided by negative 5, we have a negative divided by a negative, so we know that our answer is going to be a positive value. So since we know that, we can just address the question, what is 20 divided by 5? 20 divided by 5 is 4. Again, we know that our answer is going to be positive because we're dividing two negatives. This case is a little bit different, and in the previous slide, at the bottom here, we have a statement that says this proof here, this shows that dividing by a fraction is equivalent to multiplying by the reciprocal of the fraction. A lot of times when we come across a division problem involving two fractions, it's kind of confusing, because how do you divide by a fraction? Well, if you remember that statement on that last slide, the statement says take the division problem here and rewrite it as a multiplication problem. So instead of a division sign here, we're going to put a multiplication dot, and we just have to multiply by the reciprocal of this fraction. The reciprocal, it's still going to be negative. Signs don't change on reciprocals, but we will swap numerator and denominator to write the reciprocal. So now that we have the reciprocal, we have a positive fraction times a negative fraction. We know that our result is going to be negative. Positive times negative is negative. Multiply 3 times 2 is 6. Multiply the denominators. 4 times 5 is 20. Here we have 6 over 20. That is a fraction that we can reduce, and I did be able to identify that right away because 6 and 20 are both even numbers. So we know that it's definitely going to reduce a little bit. So we can divide both of these by 2. So 6 divided by 2 is 3. 20 divided by 2 is 10. 3 over 10 doesn't reduce any further, so our answer there is negative 3 over 10. All right, some more powers and square root examples. We've already looked at powers. We've already looked at some square roots in some previous lessons. Some special cases, though, that we want to take a look at. The question is, what is the difference between these two powers here? Is there any difference? And the hint or the clue is we need to recall the multiplicative property of negative 1. Okay, so here in this first power, or the quantity negative 4 squared, what is the base? Well, negative 4 is the base. So we're squaring negative 4. So remember, this means take negative 4 times negative 4. Simple multiplication problem. Negative times negative is positive. 4 times 4 is 16, so we know our answer is positive 16. The second problem, this is where things get a little interesting. Since here we had negative 4 in parentheses, we knew that negative 4 was the base. Here, negative 4 is not in parentheses. So what we have to assume, and then again, this is why I recall the multiplicative property of negative 1. We have to assume or think of this as negative 1 times 4 squared. The negative is not associated with the 4 as it's written. So a lot of times we handle these problems the same, but they're not the same. So if we calculate this out, negative 1, we have to do our squared first. 4 squared is 16, and then we have to multiply by negative 1, we get negative 16. Okay, clearly these are not the same. One we get a 16 and one we get a negative 16. Very, very key. Common mistake. Let's try not to let this happen. So here we have 3 possible square root situations. The first one is the one that we've already seen. Radical 64 is asking us for the non-negative square root of 64, which is 8. Second problem here, we have this negative sign in front of the radical. This negative sign is asking us for the negative square root of 121. The square root of 121 is 11. It's asking us for the negative. So the answer is negative 11. Okay, and if you remember, and I'm going to use 121 and 11 as examples, the definition of a square root was any number squared equals some number. This 11, we call that the square root. Well, if I take negative 11 and I square it, negative 11 times negative 11 is positive 121. So all positive numbers technically have 2 square roots. They have a positive root and they have a negative root. So problems when it specifies a positive root, it's going to look like this. There's not going to be any sign in front of the radical. It's asking us for the positive square root. If a problem is asking us for the negative root, they're going to put a negative sign in front of the radical, and we will answer with the negative root. This last example, this looks a little strange here. We have a plus and a minus. Okay, that's what this means, plus minus. So this is saying the positive and the negative root of 16. Positive, negative, radical 16. So this is asking us in our answer really for 2 answers. They want the positive square root of 16 and the negative square root of 16. So that's one way to write it. Or we can also answer with the plus minus. Plus minus 4 implies that we have positive 4 and negative 4 as solutions. Have a great day.